This is a Fluke digital thermometer that can display temperature readings from a thermocouple. This particular instrument is configured for a Type T thermocouple, which uses copper wire and Constantan wire. The two wires are soldered or braced together at its end, creating a measurement probe. Right now we're reading about room temperature, which is 72 degrees, and the meter can switch between Fahrenheit and Celsius, 22 Celsius. This junction is our measuring junction, which is used to drive the display, the temperature of the display. Inside the instrument is the reference junction, and there's a temperature compensation circuit that adjusts for the temperature of that internal junction using an integrated circuit temperature sensor. So that's all internal to the device. So we have the external junction used to measure temperature, and on the back of the device, where the two wires are attached, there's two junctions here, but they're at the same temperature and their effects cancel. And again, inside the device we have the temperature reference junction. As with many temperature measuring devices, you have to be aware of the delay between actual temperature changes and what is recorded by the device. So here, if I press my fingers to the measuring probe, my fingers are a lot warmer than room temperature, so the temperature will rise, but you'll see that it will rise slowly due to the time constant of the system. It takes a while for the thermal capacitance of the measuring probe to balance out with our applied temperature. So it looks like my finger's surface temperature is about 86 degrees, and it took a couple of seconds for it to stabilize to that. And when I let go, it also has a similar time constant to cool back down to room temperature. I can simulate a frequency response by grabbing and releasing the probe at different frequencies. And as you can see, the output's not changing very much, even though the temperature input to the probe is changing radically from room temperature to my finger temperature. Basically not giving enough time for the probe to cool down. The back of the device includes a label that reports various specifications for the instrument. It's shown to be configured for a T-type thermocouple, which is copper Constantan. This type of thermocouple can withstand a temperature range from negative 200 degrees Celsius to 400 degrees Celsius. It also shows that we're configured to run off a 115 volt AC line input. The device also has other options, like a battery option for portable usage that can be charged up with the AC line.